In the last lesson, we looked at the list data type, which contains a sequence of elements enclosed in brackets. Since these lists are ordered, their elements were accessed based on their index in that list. In this video, we'll look at how we can access more than one element from a list by slicing. Slicing is done with a set of indices which specifies a range, the start and stop. The start specifies the index where we want to start slicing the list. For example, if I specify the integer as 1, it will start slicing the list at index 1. The stop integer specifies the index until which we want to stop slicing. If I specify a stop integer of 8, as soon as it reaches the 7th index in the list, it's going to stop. Notice how I said the 7th index, not the 8th index. That's because the upper index is exclusive, meaning the slicing stops at that index minus 1. It's not included in our sliced segment. In this case, our lower index is 1, the lower index is indeed inclusive, and our upper index is 8. So what this will do is it will grab everything from the list at index 1 up until index 7. Let's try this out. Back to Jupyter Notebook. Declare a list ordered numbers is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There is actually an easier way to specify a list of numbers with the range function. I'll show you how to do it momentarily, but we'll just stick with this for now. And let's assume that I want to grab elements from 2 to 9. How would you do that? Well, what we'll do is we'll write out the variable ordered numbers. And to specify indices of the list, remember we need the brackets. The lower inclusive start index will be 2. And we want everything up until and including the number 9. So our stop index will be the number 10. Remember, the number 10 is going to be exclusive, meaning the slicing stops at that index minus 1, so at 9. Let's output this. Well, let's print it first and foremost. Run the cell, and we get a list that goes from 2 to 9, a sliced list. Let's assume you wanted everything from 0 to 9. Well, you can specify the start index as 0, which will take everything from index 0 up until 9. Alternatively, there is a shortcut where if you omit the starting index, it assumes that you're going to start at the very beginning of the list up until your stop index minus 1. Let's try it out. And indeed, we get the same results. Let's put 2 back as the start index. So it's going to start at index 0, 1, and then 2. And from that index, we want everything on the list up until the very end, from 2 till 10. We could simply write 11, which is the length of the list. Or if you want to get fancy, we could use the length function to obtain the length of ordered numbers, which indeed is still 11, therefore signifying a stop index of 11. But there is actually a shortcut to this. If you just omit the stop index completely, let's go ahead and do that. It automatically assumes that you want everything in the list beyond your start index. When you run the code, indeed we get the same results. This is perfect and much more concise. If you omit both the start and stop index, it'll just grab the entire list. But then again, why even slice in that case? Before moving on, I did promise that I would show you how to create a list of numbers in a more concise way. We can use the range function. That is, specify a range, and the range will be from 0 to 10. This will create a range from 0 all the way to 9. Even here, the stop index is exclusive. it stops at the number previous to it. And now I can wrap this up in a list data type. If we print it, print the list, it outputs a list in the range of 0 to 9. Super easy and much more concise than actually writing it all out from scratch. We can actually go from 0 to 100. As expected, it gives us a list from 0 to 99. Imagine writing all of this out and hard coding it. That would take a long time. If you don't specify a start index, Python will just assume a start index of 0. So if you omit this 0, we should get the same results. And indeed we do. Let's put this back, as we can also indicate a step size as our third argument. We'll put in a step size of 5, such that it will indeed still contain numbers between 0 and 100, 0 to 99, but it will only include every fifth number in the sequence. If we run this, clearly it does so in a step size of 5 numbers. If you change this to 3, the pattern follows. It includes every third number in the sequence, so on and so forth. So range is just another handy built-in Python function that one should be mindful of. Now lists, just like strings, integers, floats, and booleans, it's a data type. However, lists are most similar to strings, as in, they share a lot of the same built-in methods, like length for example. Do note that we can also index strings. To prove this, I will declare a string title is equal to, let's call this show title, is equal to Game of Thrones. If I asked you to grab the third character in the string, the M, well, from what you've learned, G is at index 0, A is at index 1, and M is at index 2. Therefore, you can index it like so. Show title, square bracket, 2. We will print this, and the output is indeed the character M. Just like lists, we can also slice a string, such that if I wanted everything from M up until the very end of the string, 2 would be my start index, colon, and remember, if you omit the stop index, it's going to automatically assume that you want to grab everything beyond your start index. And if we run this, we get Me of Thrones. That is all for slicing for both lists and strings. In the next video, we'll look at how we can use membership operators to determine whether something is in or is not inside of a string or list. I will see you then.